Hey guys, today's video is about model evaluation. We'll continue our discussion on ROC curve, but we'll focus on how to derive and interpret a ROC curve. To begin with, ROC curve is used to select a better cutoff, and it basically looks like this. It's a curve with false positive rate on the x-axis, true positive rate on the y-axis. The formula of false positive rate is Fp divided by Fp plus Tn. In fact, the denominator is just the actual negative because Fp is the negative data points that are incorrectly classified as positive. Then, true positive rate is Tp divided by Tp plus Fn. Similarly, the denominator is the actual positive. Now we can discuss how to derive a ROC curve. Generally speaking, we build a confusion matrix for each cutoff and calculate the true positive rate and the false positive rate. Then, we put a dot on the corresponding position. In fact, there are infinitely many possible cutoffs, so we can draw infinite many dots. When the number of dots become really large, they sort of look like a line or a curve, and that's how we get our ROC curve. Without further ado, let's see how it works. Assume we have this medical data with 10 participants, and we want to predict whether a person is infected by looking at his or her test result, which is the y-axis. Specifically, the blue dot means that person is uninfected. The red dot means infected. Then, we start from the lowest cutoff possible, which is 0. That is, we classify participants whose test is above 0 as positive. In other words, we classify all the participants as positive because you can't have a negative test result. Next, we can make our confusion matrix. Just to quickly illustrate, there are 7 false positive because all of the 7 uninfected participants are misclassified as infected. Things becomes a lot easier now. The true positive rate is 3 divided by 3 plus 0, which is 1. 3 plus 0 is the number of actual positive people. It's also Tp plus Fn. Now pause for a second and try to figure out the false positive rate. Yes, you are right. It's 7 divided by 7 plus 0, which is 1. It's because all the actual negative people are wrongly classified as positive. That's it. You put a dot on the coordinate 1, 1, because both of the TPR and FPR are 1. That's how we start our ROC curve. Let's look at another cutoff and practice again. This time, the cutoff is 0.5, that we classify all the participants with test result higher than 0.5 as positive. Pause now and calculate the confusion matrix true positive rate and false positive rate for this particular cutoff. Bingo! The TPR is 1 and the FPR is 0.14. Consequently, we put a dot on the coordinates 0.14 and 1. Wait, what are we doing exactly? Principally, we make a confusion matrix for each cutoff, and we calculate the FPR, TPR, and we put a dot on the matching position. Here, we put 2 dots corresponding to the cutoff 0 and 0.5 on the graph. So there are a lot of cutoffs we didn't calculate, right? We didn't calculate the cutoff 0.2, 0.3, or even smaller ones, 0.01, 0.002. If we calculate all the cutoffs, these 2 dots will be connected by a curve. Yes, that's how it works. In this case, we'll eventually have a ROC curve looks like this. The curve is super steep in the beginning, then it starts to flatten after reaching a certain point. Now you know how to derive a ROC curve, we can move on to the interpretation. In particular, how do we select a better cutoff? It's quite straightforward actually. For instance, the points 0.14 and 1 is absolutely better than the 0.11. It's because under the condition that TPR is the same, we'd like to have low false positive rate. After all, we don't want to misclassify participants. Then, as we know, the point 0.141 corresponds to the cutoff 0.5. the point 1, 1 corresponds to the cutoff 0. Therefore, we can conclude that the cutoff 0.5 is better than 0. In other words, if we only have two choices for the cutoff, we'd choose 0.5 over 0. And this can be easily inferred from the ROC curve. Actually, by looking at the ROC curve, you can quickly find out the cutoff that meets your requirement the best. For example, you might want true positive rate to be as high as possible, and you don't really care much about false positive rate, then you can simply pick a cutoff that has TPR equal to 1, regardless of the FPR. Alright, you now understand how to use ROC curve to compare and select the cutoffs, but there is something about the whole curve you need to be really careful. To quickly recap, the FPR means the percentage of negative data that are misclassified as positive, and the TPR means the percentage of positive data that are correctly classified. Thus, the point 1, 1 indicates the probability of true positive is equal to the probability of false positive. Most of the time, we don't want the model to perform like this, because FPR is too high to be acceptable. Further, if we do a random guess, the ROC curve will be on the diagonal. This means the TPR and FPR are almost always the same. It's intuitive that you can just make a guess. Sometimes you get it right, sometimes you don't. But the chance is roughly 50-50, so we get the ROC curve on the diagonal. What does this mean then? This means any point below the random guess ROC curve is unacceptable. If your cutoff performs so bad that it has higher FPR than TPR, then you don't even bother to use it. You can just make a guess. That makes sense, right? Following this, any ROC curve below this diagonal line is also unacceptable. When we talk about a dot, we are considering a particular cutoff. But when we talk about the whole ROC curve, we are discussing a classifier, such as naive Bayes logistic regression. Namely, the classifier with a ROC curve below the diagonal line performs worse than random guess. Thus, that classifier is not useful. In conclusion, we only consider the classifier with the ROC curve above the diagonal line, and for that classifier, we pick a dot that fits our requirement the best. Then we find the corresponding threshold or cutoff as final model. That's a lot. Just take your time and think about the logic behind it. Thank you for watching my video and hope you enjoyed it.